Okay, I want you to turn this into its Boolean expression. We're going to do a simple version, we're going to do a more complex version. The simple version, well, first of all, pause the video, give it a go yourself first. Simple. Okay, so we know that the end result is going to be S, so I'm going to do S there, equals. I'm then going to look at P. P is a NOT gate, so I'm just going to basically say NOT P. We've also got Q and R, so I'm going to leave a little bit of a gap. Let's do Q and R. Now they're together, so I'm going to do them in a bracket like that because they're together. So I'm going to say Q, R, and they're connected by a NOR gate. So I've done this, I've done this, but to connect this NOT P to Q NOR R, it's this OR gate. So NOT P or Q NOR R. But we're still left with this one remaining gate here. And this gate is connected directly to the R. So I'm then going to say the result of Q NOR R, which is here, is going to be then ANDed, because it's an AND gate, with R. And I put that in brackets. So that is us turning this circuit into a Boolean expression. NOT P or Q NOR R and R. Okay, so for those people who are doing this more advanced, how do we do this using a Boolean expression itself? Well, we do S equals, so it's the same. NOT P is simply a P with a NOT over it, like that. So I'm going to put a bracket here. Or we use a plus sign. We can't represent Q NOR R using a Boolean expression. So we have to do it separately. So we're going to put a Q, we've got an OR gate, and we've got an R. What's the difference between OR and NOR? This NOT. This NOT is for both of these to make it a NOR gate. So, I think I actually got the brackets wrong on the last one, so yeah, on this one, yeah, I did get the brackets wrong on the last one. This is going to be the end of these brackets, so it's these three together. However, we still got this AND gate to represent AND as a dot R. So, this really should be NOT P and then the bracket here. That's my fault. There we go. This is representing this. This is representing this. If you like to go from step 1 to step 2, step 2 to step 3, that's down to you. Or if you're capable of just doing this straight away, that's fine. Let's do another. You know the drill, pause the video, give this a go. I'm going to show it in two different forms, easy version, more challenging version. Okay, so let's do it. X equals, now, I'm going to start with A. A is connected to this AND gate, so I'm just going to say A and we've now got NOT B. That's the next gate, so I'm going to say, oops, my bad, NOT B. So I've done this and I've done that one. We've also got B connected to C, so I'm going to say what we've got is a little gap, and I'm going to say B. I'll put it in brackets because we've got B and C together, and C. B and C are connected to NOT B by this OR gate, so I'm going to put OR here. And there we go. Now let's do it as a Boolean expression. X equals A and NOT B or B and C. There we go, happy days. Pause the video, give this question a go yourself first. You know the drill. Let's do it simple, then let's do it more complicated using a Boolean expression instead. So let's turn this into x equals, and it starts off with this to this line, so it's a and in brackets we're going to have not a, and we've got not b. What joins them together is this OR gate. If we're going to represent that as a Boolean expression, it'll be a dot not a or not b. So instead of us using a circuit, we're going to have to do a Boolean expression based on this truth table. And we're going to be doing something called sum of products. I'm going to show you this in action, but I'm going to very quickly tell you what product means and sum means. Product is simply a row in a truth table where there is a 1 as the output. So if we were to go through this now, it'll be this one, this one, this one, and this one. That is our product. So we've identified our products. These products are using AND. Example. In order for this to be 1 as an output, A has to be not 1, and B has to be 1, and C has to be 1. The sum is then, okay, we've got multiple rows, we've got this row here, 1, we've got row 2, row 3, row 4. The sum aspect is combining them all together, so they say this, or this, or this, or this. So what does that actually look like? Well, let's do row 1 to begin with. If we want to turn that into a Boolean expression, we're going to have to say x has to be not 1, and b is 1, and c is 1. Now we're going to do our second row, which is this one here, so row 2. So I'm going to say OR, so now we're going to do our sum. So combining it with this, where we're going to say A is 1, and B is not 1, and C is 1. We now have our row number 3. So we need to OR it by using another sum, and now let's do our product. Our product would be A is 1, and B is 1, and C is not 1. Now let's do our final row. OR A is 1, B is 1, C is 1. So we've just done a Boolean expression for this truth table by applying the sum of the products. So the first thing we did was go for the products, look at all the 1 outputs. Then we did our sums, and then we combined it all together. Why is this done? Well, it allows us to directly translate circuits which use an AND gate representing the product and an OR gate straight away. So it allows us to translate it into this Boolean expression. So sum of products allows this to happen. Okay, so pause the video, give this question a go yourself first. We need to find the sum of products. Okay, so I'm hoping you're giving it a go yourself first. What I'm going to do is I'm going to identify every single output with a 1 for row. So that one, that one, that one, that one. So we're doing all the products here. Great. Now let's put these into a Boolean expression and combine it with the sum, which will be the OR gates. So we're going to have A, B, C, not, sorry, and, not A, B, not C. So we've done the first row, done. Or not A, not B, not C. Sorry, not A, not B, but C is 1. Or not A, so I've done this one. And B is 1, and C is not 1. Or not A, B, C is 1. Or A, not B, not C. Or A, B, C, with C, with A being that, but our ANDs there, and not B there. Perfect. And there we are. We are done. We've done the Boolean expression for this truth table. Okie dokie, so now we're going to be introducing you to this term called a K-map, kernel map. Why do we use a kernel map? Because the whole point of this, you could argue, is inefficient. There may be ways that we can actually simplify this Boolean expression. If we simplify a Boolean expression, that basically means we can create a circuit that has less gates. A circuit with less gates means it's going to be more effective, more efficient, and cheaper, less cost. A K-map allows us to identify anything which may need to be simplified. It's easy to look at common terms, identify different common terms. It's easy for us to simplify it, easy for us to minimize our logic gates being used. So we want to go from this gigantic circuit to a more simple circuit if we can. So how do we do a K-map? It's really simple. Pause the video and give it a go yourself first if you think you know how to link this to this. Give it a go. Okay, all we're doing is we're writing the results from this truth table into this table here. So we've got A, B here, and we've got C here. Notice we've got 0, 0, 0, 1, 1, 1, 1, 0 going across the top. That's the pattern. It has to be this pattern. And it has to be 0, 1 here. So it has to be laid out like this. Now what? Well, if A is 0 and B is 0, so we're looking at these two being 0, and C is also 0. What we're going to do very quickly, so A 0, B 0, C 0, the output is actually a 1, so I'm going to put a 1 in here. If all those three are 0, the answer is a 1. If A and B are 0 and C is a 1, which is the next row, the output is also a 1, so I'm writing the result in here. We then have 0, 1, 0 here, so A is 0, B is 1, and C is 0. It gives us a 1. We have A is 0, B is 1, and C is 1, and the output is also a 1. What happens if A is 1, B is 1, and C is 0? It gives us a 0. If they're all 1s, A, B, and C, the output is also a 0. And finally, if A is a 1, and B is a 0, and C is a 0, the output is 1. If A is 1, and B is 0, and C is 1, the output is also a 1. So we've just filled out a K-map. But now what? So what we're going to do now is we're going to group the ones together. You could do it as, let me use a different color, let's do green. You could do it as 1 by itself. That is allowed, so we can just do this. The issue with doing this is that, or shall I say what our aim is to make the largest groups we possibly can. So unfortunately, whilst we can do it as 1, it's not going to be appropriate because we can do it in a bigger group. We can also group as pairs. So we can say, this is a pair, this is a pair. We can also say that this is a pair. We can do that. That is allowed. But we can actually group it as a larger group. So you've got 1, you've got 2, we can also group it in 4s. We can also do it in 8s, 16, etc, 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 so power of 2. So if it's a binary, place all the values. What we can't do is do groups of 3, 5, etc. So if we look at this now, let me use a bit of a bolder color, blue. Okay. We've got a group, and let me make this thicker as well. We've got a group here. This is a group. That is one group of 4. Now you might say, okay, that's cool. And now we've also got a pair over here. Actually, what we can do is, in a K-map, it can perform a wrap. So we can actually do this. I'm going to take these two. And I'm also going to include these two to create another group of 4. And therefore we've got 2 groups of 4 ones at the moment. Now you can say to me, yeah, but we could actually make that bigger. We could have done, when we did our wrap, all of these. The issue with that, it gives us 1, 2, 3, 4, 5, 6. So remember, it's going to be power of 2. So our second group is in purple, and our first group is in blue. So we've got 2 groups of 4. There's more that we're going to do next, but I'm not going to do that yet. We're going to have another play with creating a K-map. Okay, pause the video, give this question a go yourself first. Alright, ladies and gentlemen, boys and girls, let's do it. So we've got, let's just quickly say, we've got this row, we've got this row, we've got this row, we've got this row, and this row. So, A, B, C, not, or A, B, C, not, or A, B, C, or A, B, C, where we've got not, sorry, what am I doing? We've got A, we've got not B, and we've got C, or we've got A, B, C. You can actually just do A, B, C like that. That means and. You don't need to do the dot, but we're always going to do the dot because we're not taking any risks with our exam board. So there you go. Now let's do our K-map. So 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 1 gives us a 1, 0, 1, 1, 0, 1, 1 gives us a 1, 1, 1, 1 gives us a 1, and 1, 0, 1 also gives us a 1. Okay, let's now draw our groups. We've got a pair here, and we've also got a group down here. So 2 groups, 1 of 4, 1 of 2. Okay, so the final part to this question is what we want to do, take our K-map and write what's called a simplified sum of products expression for this truth table. So what's it basically wanting us to do? Well, it's wanting us to simplify the expression. See if you can give it a go yourself first. Hint, use the pairs, or should I say the groups, to help you simplify it. Okay, so I've got one pair which is green and one pair or one group which is blue. You can see that highlighted. And what I'm going to do is work on the green first. I'm going to look at the group together, the pair together. We've got 0, 0, 0, which makes a 1. So we know that A has to be 0, B has to be 0, and C has to be 0 for it to be a 1. Or does it? Let's look at the one below that. A is 0, B is 0, but C this time is a 1. That's telling us that it doesn't really matter what C is. It's A and B which is making the difference to whether or not it's a 1 or not a 1. A hasn't changed, B hasn't changed, it's a 1. When we did make a change on this, so you'll see which we did decide to change, it didn't make an actual difference to the overall score, it's still giving us a 1. So that shows us that A and B have to be a 0, but it doesn't really matter what C is. Therefore, if we want to simplify this pair, all we have to do is say we need A and B. But what about A and B? Well, A and B are both zeros, which means that both A and B have to be a 0, which means for this to be a 1, A and B have to be a 0. We don't care about C, it makes no difference. How do we represent 0? Well, 0 is a not, so we're doing not A and not B. See if you can do the second group by yourself. So the group of 4. Pause the video. Okay, well what I'm going to do is I'm going to do an OR gate, because we're going to join this group up with our blue group. So let's do it. Let's see what makes a difference and what doesn't make a difference. Well, we've got a 1 here, we've got 0, 0, it gives us a 1. We've got a 1 here, we've got a 0, 1 here, and it's still a 1. So we've changed B already, and it's giving us a 1. That means that we know straight away B is pointless. We've made a change in that input, and it still gives us a 1. We've now changed A to be a 1, and it's still giving us a 1. So it doesn't matter if we change A, it's still giving us a 1. So therefore we know that A and B are pointless for this second group. The only thing which seems to be a constant which stays the same is C. So what we need to do is put C in, and there you go. What we have done is made a simplified sum of products expression. Let's do another. Okay, this is the final question before we take it up to the next level. Pause the video, give it a go yourself first. Okay. So 1, 1, 1, 1. A. Oh my god, I can't even write the line. Sorry, Lucas, for slowing this down. A, B, C. Dot, dot. A is not 1, B is 1, C is not 1, or A, B, C. A is not 1, B is 1, C is 1, or A, B, C. A is 1, B is not 1, C is not 1, or A, B, C. A is 1, B is not 1. What am I doing? A is 1, B is not 1, C is 1. Let me just double check the last one. Yep. Okay, sometimes it's easy to get this wrong if you rush it, like I just did there. Okay, now let's do the K-map. So we've got 0, 0, 0, 1 gives us a 1, 0, 1 gives us a 1, 1, 1 gives us a 0, 1, 1 gives us a 0, 1, 1. Okay, I'm going to group them. So this is going to be one group. It's a pair. And this is going to be my other group. It's a pair. Let's do my magic pen. Well, I should have just looped it, but whatever. Okay, write the simplified sum of products. So let's see what changes, what stays the same. Well, for this one, A is 0, B is 1, C is 0. We've got a 1. If we change C to a 1, we've still got a 1, which means that C is irrelevant. So we've got 0, 1, which means we've got A, B, and A is being a NOT gate. Or, let's have a look at this side. We've got 1, 0, 0, it's a 1. If we change C again, we've got 1, 0, 1, and it doesn't change anything. Therefore, C again is irrelevant. So this time we've got A being 1, B being not 1. And there you go. We've simplified the sum of products expression. Okay, pause the video, give this question a go yourself first, see if you can do it. This is exactly the same as what we've done before, it's just using 4 inputs instead of 3 inputs. So let's identify the rows with having a 1. This one, this one, this one, this one, this one, and this one. Everything else is irrelevant. Now the second thing is, you'll notice it's not done any labeling for us on the outside. This is so important that you understand this, that it's always going to be in this order I'm going to give you. 0, 0, 0, 0, always the same. 0, 1, 0, 1. Then what we go into is 1, 1, 1, 1, 1, 0, 1, 0. Always that order, otherwise it will not work the K-map. The next step, I'm just going to change my color to make this obvious, is we do the same spiel again. So if A, B, C, D is 0, we get 0. If A, B is 0, C, D is 0, 1, it's 0. So we're basically looking at V's at the moment. 0, 0. All of these are zeros. If we've got 0, 1 for A, B, it's always giving us a 1, so I'm just going to put 1 here. If we've got 1, 1, so let's go down here, 1, 1, 0, 0, it gives us a 1. If we've got 1, 1, 0, 1, it also gives us a 1. If we've got 1, 1, 1, 0, it gives us a 0. And if we've got 1, 1, 1, sorry, if we've got 1, 1, 1, 1, it gives us a 0. If we've got 1, 1, 1, 0, it gives us a 0. If we've got 1, 0, 0, 0, is a 0. So all of these 1 zeros are also a 0. Okay, let's do our groups. I'm going to use a different color. I'm going to now make this a little bit thicker. We've got one group here. One, two, three, four. But we've also got another 4 here. Okay. So what do we know from this? Well, we know that it seems to be that if you've got 0, 1 here and you change the inputs here, it makes no difference. It's always going to be a 1 as long as these are 0, 1. So therefore, we've got in ours A and B, with A being a NOT gate. Or, now let's join it with the group. We have, if A is 0 here, and let's look at the one next door to it, A is a 1, it stays the same, the inputs. It doesn't matter about A, because A is a 0, A is a 1, it's still giving us a 1 and a 1. So therefore A is out of my equation. B is a 1, and C is a 1, and it's a 1, 1, 1, 1. So B even, is definitely part of my equation here. But now let's go down the columns. C is 0. We've got a 1 here. C is 0. We've got a 1. C is 0. We've got a 1. C is 0. It's got a 1. Now let's look at D. So C is important. D is 0. We've got a 1. D is 0. We've got a 1. But D is 1 and we still got a 1. D is 1 and we still got a 1. So D is irrelevant. So we've also left with C. And C is 0 in both of these, so it has to be a NOT. So that is our simplified Boolean expression.